Right. So, uh, I tried uploading some of the class videos to our Canvas websites, and they don't want to go on there. So I've had to start a YouTube channel that's going to be dedicated to everything that uh, we cover in here. And then I'll just post a link. So if you are going to miss a day, you will actually be able to see the class videos now for really real, not just, yeah, I recorded them and then try to send someone the file if it's if they didn't make it to class and then realize, oh, the video is way too large, so it doesn't go through email. So, but I was just looking at it in on YouTube. Apparently, if I want to put a video that's more than 15 minutes long on there, I have to be verified. So I have to go through and do that using whatever method where I'm supposed to. And because we missed a day last week, we get to go cover 6.2 through 6.5. If any of you talked with the students that were in the earlier class, you realize that pretty much everything we're going to be doing in here is going to be using the exact same formula over and over and over and over and over again, no matter what the textbook actually tells us to do. One of the reasons for that is we have some options here. I can show you a dozen different special cases where uh, it works on certain types of problems, but does not work on other types of problems, and then leave it up to all of you to figure out uh, where you're supposed to use all of those special cases, or I can just give you uh, one formula that answers all the cases, and then instead of having to figure out when can I use this, what should I be doing, how should I be doing this, you can just look at it and go, I'm going to plug in this number here, I'm going to plug in this number here, I'm going to plug in this number here. So if anyone wants to try to memorize all the different special cases, by all means go ahead and do that. I'm not going to do any of that. I still wish there's an easier way to get to sections that I actually need here than doing all this silliness. So anyway, factoring trinomials, all of these or the way that we're going to look at them is we're going to look at all of them in terms of this ax squared plus bx plus c. So this stuff up here, forget about it. Using trial and error, I think you guys do enough of that on the exam with an emphasis on the error. So let's get rid of that one. Using the HC method, why bother? So this is going to be one of the formulas that I fully expect all of you to actually memorize. Okay. We're going to use it today probably about 10 or 15 times. So it's going to be, as I'm talking about these equation or this equation, it's going to be essentially the same thing as me continuously saying negative times a negative is and by now you should be saying is a really annoying thing you keep asking us, right? So, but I will say, having graded the exams, what are some of the biggest issues that came up? Negative times a negative is so the formula that we're going to be dealing with. So again, this is going to work once we've got an equation in the form of what I've got here. I will zoom in on this a little bit. We can use this one formula to do pretty much every problem in chapter 6, or we can learn 10 to 15 different ways of trying to solve various problems where it'll work with one version of a problem, but not another version of a problem because I'm way too lazy for this crap. We're using the one equation I've got on the board just to make it easy. And again, like I said, I expect you to actually memorize this one. Normally, I try not to have you guys memorize anything unless you need to. This is going to be one of those times when you need to, or memorize the 15 other ways that the textbook shows. So, looking at a lot of the problems that we have in here. So if we're looking at this first thing right here, it says factor x squared plus 11x plus 24. The way that and again, on an exam, if you have a problem like this, and you can look at that and you can use some other method than the formula to get the right answer, I don't care. As long as you get the right answer on your own and not taking it from someone that's sitting next to you, okay? So just really quickly, what ends up happening here is we need to find a couple factors for 24 that when we combine them equals 11. And down here you can see all the different factors that they pulled out. So 24 divided by 1. 1 and 24 are going to be factors of 24. Add them together, 25. Does 25 equal 11? No. 2 and 12, combine them, does that equal 11? No. 3 and 8, combine them, does that equal 11? Yes. So looking at that first one, when we go and factor it, and just note that when they're saying factor it, it's going to be in this form of x plus a number times x plus another number. So that's what they're actually looking for. So you can see 3 and 8. There you go. Now, something that if you don't have a graphing calculator, you might want to grab one really quickly. Something that we can do, and again, some of the other major issues that I saw on the exam, tried saying how many times graph it, then math it. So with everything that we, or pretty much everything we do here, we can actually go in and graph these. So we need to figure out what does this look like. So I can go to y equals, and we have the formula. I have no idea why it does these things. So got the formula x squared plus 11x plus 24. So I've got y equals. We'll do x. Actually, I'll clear out everything that's down here and clear out everything that's up here. So I go to x and then squared plus 11x plus 24. And now I can graph that. And this is zoomed in way too far. So let's change these to negate 10 to 10. Then change these again from negate 10 to 10. Try and graph that again. And this is what the graph looks like. So we know from the textbook that when we factor, we're supposed to get 3 and 8. But what ends up happening is when we solve it for x, the way that we're going to be doing, you actually get values that are the opposite of what they want. So -3 and -8. Those are some values those are the values that make this equation equal 0. You can plug them in and figure it out. And just a quick review on stuff that some of you missed up on the exam. Suppose we've got this equation and we're saying we want, what is say the domains of the values of x where this is greater than 0. For -3, the positive infinity, union -8 to negative infinity. We want it where it's less than 0, -3 to -8. If we want it to be less than or equal to, when we put those numbers in there, we have to use square brackets. If it's just less than or greater than, then we can use the round brackets. And I will say on the exam, I wasn't too picky about the sort of stuff. So, whatever your grade was, more than likely there should have been probably 5 or 10 more points taken off for small stuff like that. But like I told you all before, sitting in graduate level partial differential equations class, none of us remembered what the heck was the difference between square brackets and round brackets. So I figured I'd give you the break on this exam. Not the next one, but at least on this one. Okay. So we see here that it's a -3 and -8. So I'm gonna write this down. So our equation is x squared plus 11x plus 24. And I'm going to say that's equal to y. That way we can look at it and try to figure out how to put it into the calculator to graph it should we need to. Using the letters A, B, and C that we have up here, A equals, what's the numeric value in front of the x squared right there? 1. B is whatever value's in front of the x. C is whatever value's off by itself in this case. So 24. Now that we've got this equation here, I'm going to say x equals -b, so -11 plus and minus square root of b squared. And just out of practice and habit, I usually put parentheses around it because one of the things that's going to happen sooner or later is b is going to be a negative value. And we need to keep in mind that we take the square of that negative value. And then -4 times a times c. Divide that by 2 times a. So we have -11 plus and minus the square root of 11 squared. That's going to be 121 minus 4 times 1 times 24. What's that? I think that's a reason to use a calculator, right? So 4 times 1 times 24. So we get 96 divided by 2 times 1. So that's just going to be 2. Now the next thing is under the square root, do 121 minus 96. So negative 11 plus and minus square root 25. All of that is going to be divided by 2. What is the square root of 25? 5. Some of these that we do, whatever's in the square root here, it's going to be a number that we're familiar with. That doesn't mean it's always going to be that way. So we have that. So our answers, and when we look at a problem like this, and we notice that it's x squared, that's telling us there are going to be two values for x. So, which is where this plus and the minus comes in. So we have negative 11 plus 5 divided by 2, and negative 11 minus 5 divided by 2. Negative 11 plus 5 is going to be negative 6 divided by 2. Negative 11 minus 5 is negative 16 divided by 2. Negative 6 divided by 2, negative 3, negative 16 divided by 2 is negative 8. So we already saw that when we graph this, what do we get? The graph equals 0 when x is negative 3 and negative 8. Because of the way that the textbook wants it when we're talking about factoring, you have to take whatever these are and do the opposite. So in this case, the final answer would be x plus 3 and x plus 8. Okay. Going from the negatives here to the positives here, that can be a bit tricky. But the thing we need to keep in mind here is, what did we do at the beginning? Our initial step here is to actually say this entire equation is equal to 0. So what we need down here is x plus 3 equals 0. What is x going to equal if x plus 3 equals 0? It's got to be negative 3, right? If I say x plus 8 equals 0, what does x have to be? Negative 8. Okay. So that's why we have to change the sign on these. These are the exact values of x. These are the way that the textbook and probably the online homework is going to want you to write these things out, okay? So, and just to be real about it, is everything that we just did here a lot more effort than the method that the textbook was using to try to solve the same problem? Yeah. But we got the same answer. And again, if you can figure out how the textbook is doing it and you want to use the textbook method, have at it. But a lot of times and this is something that really annoys the crap out of me as a math lecturer, some of the torture students in math classes. That formula works all the time, every time, no matter what. And then we try to, in some classes, I've actually been told, do not show them how to do it this way. It's like, why not? I can take an entire chapter, maybe even 2 chapters of material, condense it down to one day, and the students will not be behind, and they'll probably get better answers anyways. So So using this is a lot more effort, but using this method does work on everything that we're going to be doing in here. At least today and possibly next week. So it is something to think about. So if we're going to try doing it with one of these other equations down here, what's the value that's in front of the t squared here? It's 1. So a equals 1, b equals 14, c equals 24. Cram it in there and see what happens. If we have an equation like we've got here, the previous one, it's basically x squared plus something times x plus a positive value. Here we've got a negative value. So if you're going to use the method that the textbook is talking about here, what do we need to do? What do we need to think about? What are some factors of positive 28 that when you combine them together give you negative, what was it, negative 4, negative 11? And again, negative times negative is up. So we have to find the factors of 28 and make sure that we have two negatives out are in front of them. And then when we combine them, do we get the negative 11? So negative 4, negative 7. Those are going to be the values that when we go and put it into our answer. So y minus 4, y minus 7, that's what we're going to put in there. But when we graph this, so we've got, even though it says y squared on here, your graphing calculator doesn't let you change, do like f of x equals y squared, blah, blah, blah. So you have to translate everything back into x squared anyways. So x squared minus 11x plus 28. So when we go and we graph this, you see that the 2 points where y equals 0 is x equals 1, 2, 3, 4, 5, 6, 7. So we have an idea of what we should be getting when we're done using our formula and all that. And again, because when we factor or when we graph it like this, we get positive 4 and positive 7. When we put it in, we have to make sure that we put the negatives on. Because again, we want to say y minus 7 equals 0. So positive 7 minus 7 equals 0. Okay. So let's take a look at the equation y squared minus 16y plus 63. So again, if we want to try to get an idea of what the answer should be, we could go and plug this into and plug it in and try to graph it. So this is going to be negative 16 plus 63. We graph that. And you see 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's telling us that y, we want to make that whole thing equal to 0. Then y, when we're finished with it, should give us about, what was it, 7 and 9? Somewhere around there. Is it going to be exactly that? No. Well, maybe. In this case, yeah, it is. But Are we allowed to look at that and say, well, it's close enough, therefore that is the answer? No, we still have to show the work. But we have an idea of what answers we should be getting. So again, using this idea here, y equals negative b plus or minus the square root b squared minus 4ac. Divide all of that by 2a. A equals 1, b equals negative 16, c equals 63. Plugging in everything, y equals negative 16 plus and minus the square roots of negative 16 squared minus 4 times a times c. Divide all that by 2a. Negative times negative is a, so just so we're clear, you're never going to escape this whole negative times a negative thing. It's going to happen over and over and over, and you're going to be totally sick of it. And then sad news is when it comes to future exams, what are some of the biggest mistakes everyone's going to make? Negative times a negative. So we now need a negative 16 squared. So I can just do that as 16 squared. That's going to be 256. Minus 4 times 1 times 63. Based on what I have here, I can actually come up here and say minus 4 times a times c. So this looks like it's about 252 divided by 2. But we're going to end up with 16 plus and minus the square root of 4 divided by 2. Square root of 4 is 2. So 16 plus and minus 2 divided by 2. So 16 plus 2 divided by 2. 16 minus 2 divided by 2. 16 plus 2 is 18 over 2. 16 minus 2 is 14 over 2. That gives us 9 and 7. So when we go to factor it, again, we have to put it in this form here, which means we take the values we have and put in the opposite. Move that out of the way real quick. So with some of these steps, but if we're talking about like how do you show your work on some of these, if you wanted to go on problems like these, if you want to fill in the spaces here and then say instantly jump down to here, I'm totally fine with that. I'm not going to mark you down for that. It's when you have your equation here, and then some of you use the graph, use the matrix solver, stuff like that to get the correct answer, but you didn't show any of the work. I still gave you a point or two, but if it was a 6-point problem, you only got 2 out of 6. So you can get the correct answer on every math problem on the exams and still fail the exam. Okay. It only happened a couple of times, but it was something that came up. If you're looking at a problem like this, what is making this problem different from what we had before? Well, the other ones, it would be something squared plus something plus a number times whatever that something is, and then a constant out at the end. Here they just move those two things around. Is there different when you're doing math, is there a difference between saying 4 + 5 versus 5 + 4? So we can rewrite that top equation instead of 2x plus x squared minus 48, rewrite it as x squared plus 2x minus 48. So going from that, flip these two around. There we have that. And then plug in your values. So A is whatever value is in front of the squared term. So 1, B is the value in front of the singular term. So 2, C is the value that's out by the constant. So -48. Plug those into the equation, and eventually you get what we need. And again, looking at something like this, let's say you don't automatically see that things have been swapped around like that. Just to give you an idea of what you're supposed to be getting in the end, what can we do? Well, graph it, then math it. So I can go back to the graphing calculator, type in y equals, and then I'm going to clear all this stuff out. So I'm going to say 2x plus x squared minus 48, graph it, and it can still graph things for you. Okay. As long as it's a function, you can graph it. And while I'm actually thinking about it, if you look on the exam, there was the question where there were 3 parts to it is, or do these points give you a function? You remember those? Well, you can actually put those into the graphing calculator and see if you can get the graphing calculator to generate a function and give you an answer. If it gives you an answer, you know it's a function. If it doesn't give you an answer and it says error, you know it's not a function. I don't think I actually mentioned that before the exam because I wasn't even thinking about it until I went to grade these things. And literally, it was like, oh, I could have just, or the students could just put the numbers in and been able to figure it out. So, anyway, but again, when we're solving for this, the numbers that we get using the formula are going to be the numbers that we have here. So this is -10, 9, 8. So -8, 1, 2, 3, 4, 5, 6. So +6. When you write it down as a factor, it's going to be x minus 6 times x plus 8, because we have to take the two numbers we have there and find the opposite of them. So looking at like these two, what do? Rearrange them. N squared minus 7n plus 12, m squared plus 9m plus 18. Make it easy. Plug them into the formula, and we'll go from there. Now, with the problem like this, it is like another step up in difficulty, but it's actually not that difficult as long as you know kind of what's going on here. So I'm going to write this down real quick. So r squared minus 8rs minus 9s squared. Look this over real quick. Looking at this problem here versus r squared minus 8r minus 9. In both of these cases, I'm going to say they're equal to y. When we go to factor them, we have to set both of those equations equal to 0. with an equation like this, we expect to come up with r plus something and then say r plus something else over here, which is the equation that we actually need to deal with. We can still fill out this basic form, but it'll be r plus something times s, then r plus something times s equals 0 or equals y. So literally the only difference is we take whatever's here and we put it on the second part of these factorings here. But again, we go in, we solve it the same way we've been doing everything else. So even though it looks like this is going to be the equation that we solve. So we know that A equals 1, B equals -8, C equals -9. Plug that into, in this case, we're going to say R equals -b plus and minus square root b squared minus 4ac divided by 2a. So we've got negative b, so -8 plus and minus the square root -8 squared minus 4 times a times c, divide all that by 2a. Negative times a negative, positive. And like I was saying before, if we're talking about show me the work that you're doing, if you get it to this point and then want to try to do all of this in one step, totally fine with that. I'm not going to worry about it. If I'm going to do that, I can come up to my graphing calculator, clear, clear. So I can open parentheses, negate 8 squared minus 4 times a, which is 1, times c, which is negate 9. So I already know that whatever's going to be under the square root is going to be 100. 2 times 1 gives me 2. Square root of 100 is 10. So I'm going to have 8 plus and minus 10 divided by 2. So we're going to have 8 plus 10 divided by 2, and 8 minus 10 divided by 2. 8 plus 10, 18 divided by 2. 8 minus 10, -2 divided by 2. 18 divided by 2 is 9. -2 divided by 2 is -1. When we plug these back in up here, we have to use the opposite. So that's going to be a -9. Since I've got -1 here, it's going to be a +1 up here. And we end up with r minus 9s times r plus s. So if we look at So here we've got the two factors. And then eventually we get the r minus 9s, r plus s, which is what we're just talking about there. So if we look at these, just to do another example problem that's similar. I'm going to look at, let's say m squared minus 13mn plus 12n squared. And I'm going to say that's equal to y. With this one, we know that at the end, so if I can get all this on the screen at once, we're going to have m plus some number times n, and then m plus some number times n equals y. We need to figure out what goes in here. So I have a equals 1, b equals negative 13, c equals 12. I'm saying m equals negative b, so negative 13 plus and minus the square root of b squared, so negative 13 squared minus 4 times a times c. All of that will be divided by 2 times a. So m equals negative times a negative, positive, plus what is the rest of the stuff that's in the square root that we have there? And that should be a 12. So open parentheses, negate 13, close parentheses, squared minus 4 times a times c. And all of you already totally know what the square root of 121 is, right? You all remember that from whatever class it was. Or you just know how to use a calculator to figure out the square root of 121. Whatever works. So we're going to have m equals 13 plus 11 divided by 2. And that should be plus and minus, I should say. So we have m equals 13 plus 11 divided by 2, and then 13 minus 11 divided by 2, 13 plus 11, 24 divided by 2, 13 minus 11, 2 divided by 2, 2 divided by 2 is a 1, 24 divided by 2 is 12. These are positive numbers. So at the end, we have to make them negative. So our answer for this would be m minus 12n. And then m minus n. And I will say as well, if you've got several of the graphing calculators that I have, I've actually updated a lot of the programs that are on there. If assuming that I have appropriately updated everything, you can actually go to this apps thing and then come down here to number 9, at least on my calculator where it says apply smult. I don't know what SMLT stands for either, but it's apply smult 2. So what we're trying to do here is something called finding the roots. And so we want a polynomial root finder. So there it is. I get to choose what order I want this to be. So just as an example, if I gave you an equation like y equals 17 x to the seventh power plus blah 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 x to the sixth power, and so on and so on and so on. You can actually plug everything in here and get the right answer. But again, this will tell you what the answer is. You still have to show me how to get there. Another thing you can do is graph the whole thing, figure out what it's supposed to look like. So a couple different options there. I'm not going to bother you with the polynomial root finder. Um, so again, looking at what we've got here, both of these are negative. Since both of these things are negative, that's telling us that when we find a factor for this, if we're looking at the numbers, not necessarily the negative out in front, but just looking at the numbers, the larger number is going to be negative. Smaller number is going to be positive. And you can use the method that's in the book. Or what do? Plug it into the equation we've been using. A equals 1, B equals -9, C equals -12. Plug it in, get your numbers, get yourself done. Not a big deal. So looking at something like this, we've got 4x cubed plus 16x squared minus 20x. So if you look at what's going on here, one of the first things that we're supposed to do is look at this and see if there's anything we can factor out. Okay. Hopefully, if you see a problem like this on the exam, bare minimum. Okay. Otherwise, we don't have any equations or anything for you to solve anything here. But just like bare minimum. Okay. X cubed, x squared, x. Hopefully, you can at least figure out that you can pull an x out of everything. Okay. If you can do that, there. So they're showing you here, you can actually do 4x. Makes it even easier for you. But I've been on exams before. Trying to see everything that you can factor out sometimes can be a bit tricky, right? So just bare minimum, we'll recognize you can pull out an x. So you pull the x out in front. A is 4, B is 16, C is -20. Put it into the equation or into the formula. Calculate your values of x. Done. If you see that you can pull the 4 out of there, awesome. If you don't see that you can pull the 4 out of there, don't worry. Why? Because the formula we have can actually handle that. All the other methods that we've been dealing with, or that they show you in the textbook on how to solve a problem like that, totally screws you over. Yeah.
Example right there, 4x taking 5. Yeah. Can't you just send like we can just look at it and see that it's 5
I'm sorry, just looking at it and say that it's.
Yeah, like, cause last semester, every time we did this, we just said what adds to for the results of the.
Well, that's basically what the textbook is trying to get you to do.
Yeah.
Yeah. So if you do it that way, that works only some of the time. So the question I have for you, would you rather have to memorize 10 different ways to solve it or one way to solve it? the one way to solve it will always work. With everything else. And just to, so that we know what's going on here. And this is actually something that's gonna come up in, the next section. So, as long as you can get the right answer on your own. But some of the stuff that like comes up in a little bit. You'll have an equation like that. That is in a special form. If you remember what that special form is, you can solve it, be done with it. Cool. If you don't remember what that special form is, you're gonna have some issues with it. We can still use, in this case, we can still use same equation. The thing here is we have A equals 169, B equals 0, C equals -4. Plug it into the equation, you get the right answer. If you look at that and you recognize that it's a special form, you can put it in there, get the right answer. If you recognize what we're trying to do with a problem like this, we're trying to figure out what are the values of X here. And we know that we find the values of X when this whole thing is equal to 0. So we even have the other opportunity to start from there. We can add 4 to both sides. How do I get X squared by itself? From here, what do I have to do? Well, I have to get X squared by itself first. So I'm multiplying. So what do I have to do? Divide it, yeah. And now we want to get X by itself. So we take the square root of both sides. And because you totally remember everything that we talked about, what was it? Last time or last week? Last time, because last week we had the exam of the day off. So last time, because you totally remember everything from that, right? It's all right up here. Since it's so new, you from at least some of you are starting to realize, yeah, just say yes. So you'll shut up and go on. So you totally remember that you can do this. Oops, that should be 4. Break it down like that. Square root of 4 is 2. Square root of 169 is 13. And there you go. Now, looking at the same thing, or almost the same thing. So what's the difference between these two? I got a negative here, I got a positive here, right? And I'll just say, because before I got to torture students for money, I had to tutor students for money and spent about the same amount of time doing it. In the math textbooks and a lot of the math classes that you've already had, as you're talking about, you can sometimes look at it and figure out what's going on here. But then what's going to happen on the exam, they give you something that looks very, 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 very similar. Not exactly the same, but very similar. So going from here to here looks very similar, right? If you put that into Or if you try to solve for that using, say, the graphing calculator, it's probably going to give you an error. Why? Because if we plug it into here, we're going to get the same answers. The problem is because this side is equal to 0, put the 4 on the other side, we get the negative over here. And then to get x by itself, if we kind of take this out in one extra step. Because over here, we're trying to take the square root of a negative value. If you put this in your calculator, it's going to give you an error. And that's one of the things that is going to happen. They try to build up your confidence with, I can do it this way, I can do it this way, I can do it this way. Then they give you something that looks very, very similar. Not exactly the same, but very similar. You look at that, you recognize it as being, I can solve this one about the same way that I can solve this one, go through it. You've got multiple options for that. And then at the end, with this equation here, your calculator tells you did something wrong. If you try putting that into a, like say MATLAB or some software mathematicians use to solve problems, it'll actually give you the correct answer, as long as you have the setting for it. And just to give us an idea of what these graphs actually look like when we graph them, so that you can be prepared for, is there an answer I can even get? Okay. So we can see the two equations. So I'm going to clear this one out. Said I want to clear this one out. So 169 x squared minus 4. And then graph this one, 169 x squared plus 4. So the blue is the original equation we had. The red one is the new equation that we are going to have when we graph these. They look like they're overlapping. So let's change the window on this to say, let's say -2 to 2. Let's see how that works out. Now you can see a little bit more clearly what's going on here. So the blue one, you can see that it crosses a y equals 0. Get your number. Does this cross y equals 0? No. So that means you're going to have a complex number when you're done with it. Okay. So, like I said, you can use whatever method you want. If you can look at, say this, and again, you recognize that you can pull out the 4 and the x. You can then look at this. If you're good with the other methods, go ahead and use them. So what are two factors of -5 that when you combine them together, you get +4? +5 and -1, right? And then 5 minus 1 is 4. So you can figure it out that way. But if you're looking at this and you don't instantly see that, then what? If I gave you uh then I'll let you key and see what I'm writing yet, and I'll move this out of the way in a moment. Now, if I give you something like that, I can at least pull the X out, right? If you're good, you'll notice that you can also pull out what other value. 13. So again, if you're good and you see it instantly, cool. I can do 13x. What's going to be left over? Now, any of the methods that you learned last time, can you use them and apply them to this situation? Well, you can eventually. Or you just A equals 13, B equals 3, C equals -2. Plug it into the equation, get the answer. Your choice. And problems like these are literally one of the things we're supposed to go over today. So again, a lot of the math problems, they try to get you to use a certain method over and over and over and over and over again. Build up your confidence with that method. Then they try to mess you up by giving you something that you've kind of seen before, but when you try to apply the methods they taught, it does not work. So again, looking at what we have here, hopefully you at least recognize you can pull out a Y. Should also be able to pull out a 6. At least pull out an X. Hopefully you recognize you can pull out a 5X. Simplify it. And once you've done that, you can use the method that you were talking about last time, or use the method that I've been teaching. And if you do it right, and if I do it right, we get the same answer. I couldn't care less. But then we have that. So again, the method I'm showing you works with this. The method that you were talking about does not work with this unless you try to break it down and try to cheat it down the way that they're doing it here, then eventually you can get there. Or A equals 3, B equals 5, C equals 2, plug it in the equation, go. What would you rather do? So I'm not trying to make fun of you. I fully understand where you're coming from. If it works for you, it works for you. Awesome. If it doesn't work for you, or that those methods won't always work for you, but this is still trying to get you to do guess and check, trial and error. How about instead of a trial and error, we just do it? So like here, based on what we have here, if you, again, if you want to try using what the textbook is trying to show you, you'll have 3y at one part and y 3y plus some value on one side, and then y plus another value on the other side. If you know how all this stuff goes together, you can undo it. Or plug it into the equation and figure it out that way. Now, the problems like these, I'll just tell you right here and right now. Let's see, where does it give the answer? So when we're looking at the way that this is written out right here, we have y plus 7. If you use the method that I was showing, one of the values you're going to get for y will be -7. And then you have to remember -7 goes in here, -7 plus 7 equals 0. So therefore, this has to be plus 7. When you do this side, you're going to get y equals -1/3. So you won't have 3y plus 1, you'll have y plus 1/3. And then how do you deal with that? And literally, as far as I'm concerned, if let's say this is a problem on the exam, and you say y or quantity y plus 7 times the quantity y plus 1/3, I'll give you full credit for that. I don't care. According to the book, though, you should have 3y out in front here because we're looking at something like this. Again, if the book is going to expect you that you have, like, say, 2a plus a value times a plus a value. When you do it my way, instead of 2a out in front, you're going to have a plus like a half or 3/2 or something like that. When you look at something like this, so I'll actually do this one or do something like this one on paper so we can see what's going on here. So 4b squared plus 5b plus 1. So in something like this, one of the things that can happen is we can have a 4b plus something here, then b plus another thing over here. Or another option, another possibility is going to be 2b plus something here and 2b plus something over here. Okay. Both of these will work. It's just one will give you the answer the textbook expects you to get, the other one gets you something totally different. Okay. So I'm just so that we can kind of see what's going on here. I'm going to call this E and F. If I FOIL this, 4b times b, 4b squared, so outer plus 4 FB inner plus EB, and then at the end, E times F. So this would give us 4b squared plus 4F plus E times B plus E and F. So looking at what we have here, 4F plus E would have to equal 5. E times F would have to equal 1. Go. Is there anything there? Can you quickly come up with any values for E and F that you can plug in that satisfy both of those equations? That's basically the way the textbook is trying to do it. If we do it look like this. Again, FOIL it. 2b times 2b, 4b squared, plus 2b, so the outer, 2bj, plus the inner, plus 2bg, plus the last, plus, or, yeah, bg, and then gj. Now we look at this. And based on what we have here, that's going to be equal to 5. G times j is going to be equal to 1. Again, can you quickly come up with values for G and J that satisfy both of these equations here? Not really. Sometimes you can get lucky and figure it out, sometimes not. But if we, and I know this is going to get really confusing here, so I'm going to rewrite this. We start off with that. X equals negative b plus and minus square root b squared minus 4ac divided by 2a. Plug in our numbers. Negative 5 plus and minus square root 5 squared minus 4 times a times c divided by 2 times a. Can you work with those numbers and figure out what values we're going to get? So again, I don't care how when you're solving for the b's, the x's, the y's, or whatever, I couldn't care less how you do it. It's just there's one way that's going to work with all of these every time, no matter what. And then there's going to be, when it looks like this, you do it this way. When it looks like that, you do it this way. When it looks like this third thing, you do it a third way. When it's this fourth thing, you do it a fourth way. When it's a fifth thing, you do it a fifth way. What's easier for you to do? Remember 10 different ways to solve 10 different types of problems and learn to recognize all 10 different variations or one equation. I'm trying to make it easy. And I will fully admit some of the problems we're going to do. You can do it with the, you can solve them with this equation, but I wouldn't, because they're just a lot easier to solve a different way. But those are very special cases. Okay. So, and again, factor completely using trial and error. Well, how about we just use a better method, be done with it. Again, looking at this, there's nothing that we can factor out immediately. So let's just say though, instead of the equation that we have here, let's say we had 6b squared minus 12b plus 24. Okay. So instead of the equation that's on there, let's say this was the equation that we had. First thing we'd want to do is look and see, is there anything we can factor out initially? And when we're looking at this, keep in mind, we want to figure out what are the values of b when this whole thing is equal to 0. So I've got the 6 out in front here. Should I decide to divide everything here by 6, b squared minus 12 divided by 6, so that's going to be 2b, 24 divided by 6 plus 4. Then out here I'm going to have 0 divided by 6. What is 0 divided by 6? Just 0. So even though we started off with something that looks a lot different, we can actually work with something that's a lot easier to deal with. And again, if you look at a problem like that and you see that you can factor out a 6, do it. Makes things easier. If you don't see that you can do that, then you can just plug the numbers into the equation that I've been showing you. You will get the right answer, assuming you put in the right numbers and put the right numbers into your calculator, okay? So again, this is a thing where if you want to use the textbook method, you have to recognize what you can pull out, number one. Then number two, try to figure out which method from the textbook you need to use that fits this type of equation. 3, be good enough at that method to get the right answer. Or just use the one equation, plug in your numbers. No real thinking involved, just plug and chug. And based on what happened to a lot of you on the first exam, would you rather be plugging and chugging? Or would you rather be spending 2 or 3 minutes trying to figure out, okay, what method do I use here? I know most of you got the exam done before the end of class, so good on all of you. But a lot of the time, would you rather have a method where you can just start working on it, or one where you have to think about it for 2 or 3 minutes and then start working on it? What's your choice? So a lot more of these where, so with this one, what ends up happening, if you use the method that I have, so this is 18x squared minus 37xy plus 15 y squared. So with this one, when you go and you write it out, what's going to happen is you have x plus some number times y, and then x plus some other number also going to be times y. Because you've got a negative and a positive here and a negative here, these are probably both going to be negative values here. And both of these numbers are going to be fractions. Okay. Now, this isn't the answer for this problem, but let's say we've got another problem and you use the method that I'm talking about. So you get x minus 3/7 y and x minus 4/9 y or something like that. If this is what it came down to and you put that on the as your answer on the exam, totally fine with it. For the online homework though, more than likely what they're going to want is something like that. So just be prepared for it. So what's the difference between this and this? Up here, I multiplied this entire thing by 7. 7 times 1 is 7 minus 7 times 3. So 21. 21 divided by 7 is 3. And over here, take the 9, just basically move it out in front of the x. Just make it easy on yourself with this one. Okay. So, and again, I'm not saying that this is the answer for this other problem, but when that comes up, because on these types of problems, it does come up, you can be prepared for it like that, okay? And as we go through a lot of these other problems in here, again, up here you can factor or you might be able to factor something out, you might not be able to, but you're gonna have x minus something times y and then x plus something times y for both of these here. Now, looking at a problem like this is where it gets a little bit more difficult. Because if you notice, it's y to the fourth. The 4 up here means there's going to be 4 different values of y that you get. So if you factor out the y squared, even if you don't recognize that you can pull out a -5 from here, but you at least realize you can pull out the y squared. -5y squared. That whole thing right there is going to be equal to 0. So -5 times what value gives you 0? 5 times what gives you 0? 0. So in this particular case, 2 of the values of y that you're going to be solving for are 0. Okay. And a way that we can tell if that's what's actually going to go on. So again, if we come up and we graph this, and with all this, I'm literally going to pretend that we don't recognize anything. We're going to pretend that you're totally stressing yourselves out on the exam, which I think most of you do naturally anyways, right? So let's take a look at the equation that we've got here. So it's negate 10. Again, because the graphing calculator only deals with x, we'll do x caret 4. I have to hit the arrow button over minus 55 x caret 3. Hit the arrow button over minus 60. And then I can say x and squared. Then graph that. So based on the range that we have here, that's a little bit too small. So let's expand this to -10 to +10. So now if we graph this again, what we're seeing is one answer is here. So -1, 2, 3, -4. We'll have another value that's about -1.5. Then because this comes up, touches, and then comes back down again, that's telling you that there are 2 answers right there. So we should, when we solve this, should get -4, about -1/2, 0, 0. Okay. And looking at what we have here, plug in everything into the equation, and that's about what you're going to get. There's essentially only one other type of problem that we actually have to deal with in here. And I'm trying to get to it as quickly as possible. So with an equation like this, again, everything that we've been talking about, it's we're looking at it when it's in the form of ax squared plus bx plus c equals a value. Here we have x to the 4th. Here we have x squared. With the problems like these, we have to use substitution. And you can kind of see by going through the example problem what's actually going on there. They substitute u for x squared, solve for everything, and then at the end they have to back substitute. So when you factor this using say the methods that you already know, that's what you're going to get, right? -5 and +1. You then have to back substitute x squared in for the u's. In here, what's really weird is we have x squared plus 1. We want to make that equal to 0. How do you solve that? Well, you can plug it into the equation that we've been talking about, or you can say x squared plus 1 equals 0. Subtract 1 from both sides. Now you'll have x squared equals -1. Since you now have x squared equals -1, take the square root of both sides. You get x equals plus and minus the square root of -1. Put that into your calculator, you get an error. But that's actually I. And then the values for x that we're looking at here, those will be plus and minus the square root of 5. Now, if you look at this original equation, how can we look at that and tell that there's going to be these answers that involve square root of I? Well, we can graph it. So come up here, clear all this stuff out. Clear all this stuff out down here too. So we have x to the 4th, arrow over, minus 4x squared, arrow over, minus 5. Then we graph that. Looking at the graph that we've got here, we should have 4 different answers for x. One is here, one is here. So these are the only 2 what we call real answers you can get. This is telling you that there's a complex answer that we're dealing with. So that's where the plus and minus square root of I comes in, okay? So for something like this, if you go to put in the answers for it, you'll only have square root of 5, positive square root of 5 and negative square root of 5, okay? Looking at some of these, and if I'm honest, everything that we've looked at already, once we've done this, that's pretty much everything we need to cover today. So it's almost over. Almost. So if we look at h to the 4, or 4th power plus 4h squared minus 12. Again, I'm going to say that equals y. I can plug this in and try to graph it as x to the 4th plus 4x squared minus 12. See how many times does it go back and forth through the x-axis. But the thing that I need to do here is I'm just going to come out and say x equals h squared. And again, because you totally remember everything that we went over last time, right? You totally remember that that is equal to that, right? Totally remember it because we talked about it how many times on Tuesday? And we totally didn't go that quickly either, right? So using this, because h squared is equal to x, we're going to end up with x squared. So using these substitutions, h to the 4th is now going to become x squared. Plus 4h squared is now going to become plus 4x minus 12 equals y. Now we can go in, set our equation equal to 0. We'll get x plus some number times x, because we have a positive and a negative here, minus some other number equals y. Now that we've got it in this form, if you can use one of the methods you were talking about earlier, go for it. If you can't, okay. But if you can use it really quick, or if you can use that other method, what do you think your values are going to be here? Mhm. So now the next step here, and this is where it gets a little bit trickier, we have to back substitute. We know that x is equal to h squared. So we get h squared plus 6, h squared minus 2. Now, if you look at this one here, h squared minus 2 equals 0. We can add 2 to both sides. We get h squared equals 2. Square root of both sides. H equals plus and minus the square root of 2. And you're all happy. Fortunately with this, h squared plus 6 equals 0. Subtract 6 from both sides. H squared equals negative 6. Take the square root of both sides. We get h equals plus and minus square root of negative 6. If you try to do that in your calculator, you get an error. But what we have to do is something like that. So at the beginning, we had h to the 4th power. We have I times the square root of 6 and negative I times the square root of 6. Those are two answers. Square root of 2 and negative square root of 2 are the other two answers. So there's your 4. Okay. If I do, and this is actually something that they didn't bother to do in here, but I'll get to eventually. So let's say we have something like this. I can come in and say u equals, say, x cubed. And because, again, using the idea that we had or talked about last time, we know that we can break up the x to the 6th power into x cubed squared. So rewriting this, you get u squared plus 5u minus 17 equals y. Go forth and solve it. At the end, you're going to have, in this case, u plus something, and then u minus something. But you have to remember to bring it back and back substitute. So the final answer is going to be x cubed plus some value, then x cubed minus some value is equal to y. And if you look at this equation, then you can already tell what values you put in here. Again, awesome. If you can't, that's what the formula is for. And here they've got some values that are a little bit more complex for when we're substituting. It all follows the same pattern. So again, instead of x minus 5 squared, we'll have u squared plus 6u plus 8. Factor that. What are some factors of 8 that when you add them together gives you 6? You'll end up with u, u plus 2 times u plus 4. Back substitute x minus 5 in for the u, combine, and you're done. So here are what are called perfect squares. Um, again, if you can look at these patterns and you can recognize these patterns in whatever it is you're dealing with, awesome. If not, you can literally go through and solve them the way that I've solved everything else. You will get the same answer. It's just it'll take you a little bit while longer. So if we're looking at like this 4x squared plus 12x plus 9, if you use the method we've been talking about, a equals 4, b equals 12, c equals 9, plug them in, solve for x, you're going to get the right answer. If you use the method that they're talking about, that should actually factor out to be 2x plus 3. Here's another special thing. Again, if you notice it and recognize it immediately, awesome. If not, you can still go in and do the method that I was showing you earlier. You will get the right answer, just takes a little bit longer. Here again, same thing. If you recognize this as a special formula, you can plug in the answers and be done with it. If you don't know the special formula or don't recognize that as part of the special formula, plug in A equals 36, B equals 84, C equals 49. Solve it the way we've done everything else. Here, we need to recognize that you can pull out a y value from everything as well as at least a 2. And this thing here is showing you that you can pull out at least a 4 factor the way that you expect. So an equation like this, and I will just say in this one special occasion, when you have an equation like this, okay, you can plug everything in the way that we did. A is 64, B is going to be 0, C is going to be -1. Plug it into that equation, you'll get your 2 values of y. Is there a faster way that you should be doing these? Again, looking at this, 64y squared minus 1. We want to make sure that that equals 0. So in this case, we're going to have 2 options. We can say A equals 64, B equals 0, C equals -1. Plug it into the formula, be done with it, or add 1 to both sides. 64y squared equals 1. Divide both sides by 64. Y squared equals 1 over 64. How do I get y by itself? Square root of both sides. So y equals square root of 1 over 64, which you all totally remember is the square root of 1 divided by the square root of 64. Square root of 1 is 1. Square root of 64 is 8. And these should all be plus minus. So this is one of the few times with any problem that we're actually going to be dealing with in here when using a special form is what you should be doing. Okay. So if we look at some of these other example problems here, with these two right here, what's our first step going to be? Add 1 to the other side. Divide by the numbers out in front of the square terms. And take the square root. So 1 divided by 121, square root of that, plus or minus 1 over 11. 1 divided or plus or minus 1 divided by 9 when you do this bottom one out that same way. Here, same basic idea. With something like this though, set that whole thing equal to 0. 144x squared equals 49y squared. Divide both sides by 144, and then take the square root, and eventually you get the stuff that's actually down here. Do one of these really quickly just so we can see what's going on. So if I have 121p squared minus 9q squared, so with all of these, what I have to keep in mind is that I'm going to have something times p plus something times q, then something else times p plus something else times q. Looking at it here, add 9q squared to both sides. Divide both sides by 121. Square root of both sides. And again, you totally remember that you can break this down as square root of 9 divided by square root of 121 times the square root of q squared. Square root of 9, so plus and minus. Square root of 9 is 3. Square root of q squared is q. Square root of 121 is 11. So when we go and plug this in, p plus 3q over 11, then p minus 3q over 11. To get it in the form that the textbook or the online homework wants, we'll end up with so with these, we take whatever's in the denominator, plug them out in front, be done with it. Okay. And that is literally everything that we need.